Hello everyone. In this video, we will learn how to find the sum and product of the roots of quadratic equations. Now take note, the roots of a quadratic are defined as negative b plus square root of b squared minus 4ac over 2a, and the other one is negative b minus the square root of b squared minus 4ac over 2a. Now, if we are asked to find the sum of these roots, we will simply add these two. So, with this, since they are similar terms, we will have negative b plus the square root of b squared minus 4ac minus b minus the square root of b squared minus 4ac all over 2a. Now with this, we can simplify. Negative b minus b is negative 2b. Since this is plus and this is minus, and they are the same terms, so therefore you can cancel. And the denominator is 2a. So with this, we can cancel 2 and 2, so therefore we will have negative b over 2a. Take note, this is the sum of the roots. Another, the product of the roots, we will simply multiply this 2. Now take note, this is sum and difference of the same roots. So with this, we will simply square the first term minus the square of the second terms. So therefore, negative b squared, it's b squared, and with this we can cancel the radical sign and 2, and we will have negative quantity b squared minus 4ac quantity all over 4a squared. Now to eliminate the parentheses here, we will simply distribute the sign inside. So with this, we'll have negative b squared, negative and negative, that's positive 4ac over 4a squared. So at this point, we can cancel b squared minus b squared. So we're left with 4ac over 4a squared. We can cancel 4a and 4a here. So what's left is c over a. So this is the product of the roots. Again, sum of the roots is defined as negative b over a, while the product of the roots is defined as c over a. Now let's have an example. In this case, find the sum and product of the roots. Here, the value for a is 1, the value for b is 4, and the value for c is positive 3. Now take note, the sum of the roots is defined as negative b over a. So let's substitute. So this will become negative 4 over 1, or it's simply negative 4. While the product of the roots is defined as c over a, so we will have here 3 over 1, or simply 3. Now take note, by factoring, we can factor this as x plus 3 times x plus 1 equals 0. Or we can find the roots as negative 3 and negative 1. Now let's check. Sum of the roots would be negative 3 minus 1 is negative 4, which is exactly the same with this one. Now, for the product of the roots, we will simply multiply. Negative 3 times negative 1, that's positive 3, which is exactly the same with this one. Another example. In this case, the value for a is 1, the value for b is positive 2, and the value for c is negative 8. Now take note, the sum of the roots, it's negative b over a. So therefore, this would become negative 2 over 1, or it's simply negative 2. While the product of the roots will be c over a, or it's negative 8 over 1, or it's simply negative 8. Now again, by factoring, we can have the factors here as quantity x plus 4 quantity and quantity x minus 2 quantity equals 0. Therefore, the values for the roots could be negative 4 and positive 2. Let's check. Sum of the roots. Negative 4 plus 2 is negative 2, which is exactly the same with this. Well, the product of the roots will be negative 4 times 2, which is negative 8, which is exactly the same with this. Okay. Now, at this point, what if the roots are given? How to find the quadratic equation? So if the roots are negative 5 and 12, find the equation of this. Now, there are two ways in solving this. The first method is we will rewrite this to factor form, in which if this is negative 5, so it's x plus 5, and the other one would be x minus 12. Now, using the FOIL method, we will have x squared. X times negative 12 is negative 12x, 5 times x is 5x, and 5 times negative 12 is negative 60. Next, combine negative 12x and 5x, we will end up with x squared minus 7x minus 60 equals 0. So with this, negative 5 and 12 are the roots of the equation x squared minus 7x minus 60 equals 0. Now, another method. Take note, the standard equation of quadratic formula is ax squared plus bx plus c equals 0. Now, dividing this entire equation by a, we will end up with this. This is x squared plus b over ax plus c over a equals 0. Take note, this b over a is simply the negation of the sum of the roots, while c over a is basically the product of the roots. So let's have this. Now, the sum of the roots here would be negative 5 plus 12, which is 7. So take note, negative b over a is equal to 7. So make this positive, so b over a will be negative 7. Another one. For the product of the roots, it's basically negative 5 times 12, which is negative 60, which is equivalent to c over a. Now, let's substitute this in this equation. So with this, x squared, our b over a is defined as negative 7. So it's negative 7x plus our c, which is negative 60, so minus 60, which is exactly the same with method 1. Another example. Now, if the roots are negative 3 and 4/3, find the equation. So with this, using the first method, we will have x plus 3, and the other one would be x minus 4/3. Or we can simplify x plus 3 and 3x minus 4. So using the FOIL method, x times 3x is 3x squared, x times negative 4, negative 4x, 3 times 3x is 9x, and 3 times negative 4 is negative 12. Now, combine then these like terms, we will have 3x squared plus 5x minus 12 equals 0. Now, considering method 2, let's identify the sum of the roots. So with this, it's negative 3 plus 4/3. We will have negative 5 over 3. So make this positive, so it's b over a. It's positive 5 over 3. Now, for the product of the roots, it will become negative 3 times 4/3. You can cancel 3, so we will end up with negative 4. Now, substituting this in this equation, we will have x squared, 5 over 3, which is our b over a, x, and our c is negative 4. So with this, eliminate 3 by multiplying the entire equation by 3. So with this, it will become 3 times x squared is 3x squared. We can cancel 3 and we're left with 5x. And 3 times negative 4, it's negative 12, which is exactly the same with the answer in method 1. Another example. Now in this case, the roots are quantity 3 plus square root of 5 and quantity 3 minus square root of 5. Now take note, the roots here, it's already binomial. So it's best to use method 2. So with this, let's identify the sum of the roots, in which it's 3 plus square root of 5 plus 3 minus square root of 5. So with this, 3 plus 3 is 6, and square root of 5 minus square root of 5, we can cancel this. So negative b over a is 6, or basically, b over a is negative 6. Another, the product of the roots will be 3 plus square root of 5 times 3 minus square root of 5. Now take note, this is sum and difference of the same terms. So to do this, square the first. 3 times 3, it's 9. And square root of 5 times negative square root of 5 is exactly 5. So 9 minus 5, we will end up with 4. Substituting in this equation, we will have x squared negative 6x, and our c over a is 4. So therefore, x squared minus 6x plus 4, the roots are 3 plus and minus square root of 5. Another example. In this case, the roots are 5 plus 2i, and the other one is 5 minus 2i. Now to do this, let's find the roots, sum of the roots, which is 5 plus 2i and 5 minus 2i. In this case, we can cancel 2i and negative 2i. So therefore, 5 plus 5 is 10. Our b over a is negative 10. Well, the product of the roots, it's quantity 5 plus 2i and times 5 minus 2i quantity. So with this, it's sum and difference of the same terms. So square the first, that would be 25. Now 2i minus 2i is actually 4i squared. Now take note, the value for I squared is negative 1. So substitute this by negative 1. Negative 4 times negative 1 is 4. Or basically, our c over a is 29. Now substituting this in this equation, we will have x squared. b over a is negative 10x. c over a is 29. So therefore, the roots 5 plus and minus 2i has the equation x squared minus 10x plus 29 equals 0. So that's all about finding the sum and product of the roots of quadratic equations. Thank you.